Let's say at the beginning of the month you have $115 in the bank. In the middle of the month, you make a withdrawal of $100. How much do you have in the bank at the end of the month? Can we use the formula initial plus change equals final for this problem? And the answer is yes. And the formula doesn't actually have to be modified in order to account for the fact that we're going to be subtracting, because a variable can inherently hold either a positive or negative sign inside it. So the change can be negative. So you start off with 115. We're going to make a change of negative 100. And we can solve for the final. The final is $15. So did the formula initial plus change equals final work? Yes. The change was negative. And as we'll see in this section, it's actually really important to keep track of the signs of the quantities. They make a big difference to the problems. Let's try one more. At the beginning of the semester, a college class had 25 students enrolled. On the second day, 3 students added. On the third day, 5 students added. And on the fourth day, 2 students dropped the class. How many were enrolled in the class after the fourth day? So here we have multiple changes. There's going to be an initial and then a first change of an addition of 3 students. We'll have an addition of 5 more. Then we have a subtraction of 2. And that's going to give us our final. Final answer will be 31. Did the formula initial plus change equals final work for this question? It did work, but there were multiple changes. And that brings us to the formula initial plus change 1 plus change 2 plus change 3 plus perhaps ... if necessary equals a final. That's a formula we'll use often as well. What we'd like to do next is we'd like to connect the arrow diagrams with the formulas. Let's try it in this problem. You have 4 rocks in your pocket at the beginning of a day. Throughout the day, you add 6 rocks to the pocket. How many rocks are in the pocket at the end of the day? So, we had said before that we want to start our arrow diagrams from 0. Then let's go to our initial amount of rocks, which is 4. And I actually want to label that arrow now. That's going to be the initial arrow. So I'll label it with an I. Initial always goes from 0 to some other location. Or I suppose the initial could be 0 itself. And then in that case, you wouldn't go anywhere. Now we want to make a change of adding 6 rocks to the pocket. So let's go from our initial position to the new position and give that the letter C for change. Now what we want to do that's new, that we hadn't done before, is we want to draw a final arrow. And where do you think the final arrow goes from and to? Well, a final arrow actually goes from 0 to where we land up after the change is made. So it'll look like that, and we'll label it with an F. If we like, we can just put a dashed line here to make it clear that both of these arrows, the F and the I, start from 0. Now our arrow diagram is complete, but we also want to create a formula which tells the same story. And we want them to be consistent. So in our formula here, I'll just start with the initial plus change equals final formula. And we're going to want to put in the numbers here and just see if it all adds up. So there were 4 rocks plus 6 rocks equals the final. The final is going to be our unknown quantity here. The 4 and the 6 were given. They actually asked us for the final. So let's solve the equation. Now we want to ask ourselves, does the formula in the arrow diagram tell the same story? And it does, because the final has a magnitude of 10. And we also see that the length of the final arrow actually is 10 as well. So that's good.